Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Leveraging knowledge graph with Langchain and Neo4J. A primer on Neo4J and knowledge graph at the speed of light. Before I dive into the challenges that is solved in this particular discussion, I would like to show you the inspiration that caused me to talk about this Neo4J. This is the blog written by Thomas Bratanic. He has published this in Neo4J developer blog, and he has done a very important contribution. That is to bring a new idea to an already challenging problem. So what is the challenging problem? The challenging problem is the question answering with the documents. So you must have come across lots of applications where you upload a PDF to a vector data store, and you use a large language model like whether it is chatgpt or Bard. You can use those large language model to query the documents. So there are lots of videos that I've already covered, so you can take a look at these videos on LLM where I cover that particular application where you connect the large language model to the vector store. Also, if you take a look at the popular videos, also I have discussed a lot in detail about connecting the large language models like chatgpt with the vector stores. How this particular discussion is different from that, though the regular discussion. The key challenge, if you go through this blog, right? So if you come down, the main problem which the regular vector data store faces is that, okay, let me go down a bit further. So there is a lot of documents at the top. When you retrieve the documents from your vector data store, you can retrieve up to 4 or 5 or whatever numbers you are asking for, and it will provide you the nearest documents, k nearest documents to your query. But in reality, there will be more documents that is hidden down inside the vector data store, which will not be readily available for your large language model to query directly. That is the main challenge. And Thomas, in this particular discussion, he introduces an alternate process or an alternate strategy that uses knowledge graphs. I was aware of knowledge graphs earlier, and I had discussed a bit about this in my very preliminary discussions on ChatGPT and fine tuning. At that time, I was not aware of the power of knowledge graphs. But after this particular blog, I felt that this particular strategy has to be shared with all of you. This discussion that I am going to have today is actually a primer. So knowledge graphs are like any graph. So it will have nodes and it will have relations, and these nodes and relations will be inside a particular domain, which is called as a label. And each of these nodes and the relations can have their own properties. This is graph, right? But Neo4j is a graph database, meaning it can store the graphs like this. These graphs you see here, Neo4j can store it. So that's a database. Why am I talking about Neo4j? Because I have to work with knowledge graph, and knowledge graph has to be stored somewhere. For storing such a graph, we need Neo4j. And in addition to that, the blog written by Thomas Bratanic is not just one blog. So it is a series of blogs. And just give me a moment. Let me go to the browser. And if you take a look at this GitHub repository, and if you actually go through the GitHub repository, you can see that it is not only one blog or one article he has written. He has written a lot of articles, and he has given a lot of backup information also. So Thomas Bratanic by himself has contributed a lot more information surrounding the knowledge graphs. And that is when I realized, okay, this particular topic is not just one single video. It's going to be, or it's not going to be one single day or 2-day activity. We have to dive deeper into this. So what has happened is I'll be sharing this particular blog with you guys also, or you can actually go to this blog directly. I would really suggest that follow Thomas Bratanic. I don't know him and he doesn't know me, but the way he has contributed. I really liked it. He solves a lot of problems. I feel that you guys have to learn from him also. Coming to the discussion, when it comes to the current discussion, what I am going to talk about is to the idea of representing relationships. Whether we have been always working with tables and data for a long time right now, whether you are using Excel sheet or you are using the Spark data warehouse, at the end of the day, everything is tables and columns, and all these tables and columns have joins, right? So there will be a kind of relationship between order details and orders, products, and supplier. So there will be lots of relationships, but all those relationships will be just joins. But in case of graph database, I found that it's much more interesting, because relationships can be expressed in more detail. This is one of the key aspect of graph database. So if you are going to say product 1 is related to supplier 2, you can create a relationship graph which actually talks about the relationship type, whether the supplier is supplying or whether the supplier is providing a service, or whatever kind of a relationship. You can actually create that kind of a relationship and store that also inside the graph. This is one of the difference that we see in the graph database. In case of regular RDBMS, there will be a join. So there will be a join stating that, okay, the product is linked with this supplier, and the join is the product ID and the supplier ID. That's how it works. But here on top of those joins, you can tell what kind of relationship. Like here, iRobot and Thor is linked, but in what way? So they met. Basically, meeting iRobot meeting Thor is the relationship. Here also the relationship is having a direction. You see there is an arrow mark. So here it means iRobot has met Thor, but it's not the other way around. But in this case, you see Thor has met iRobot and iRobot has met Thor. So what is the difference? I mean, when someone meets, both of them meet, right? The key point here is who initiated the meeting. So whether Thor initiated the meeting or iRobot initiated the meeting. If both of them initiated, I mean, they saw each other and they came together and spoke, then yeah, both of them initiated the meeting. So that is a kind of a relationship that you can understand from this graph database. Additional point I wanted to highlight as we are discussing this is this particular node you are looking at, this particular circle, contains not just the name, it contains various other properties like the weight, the location, etc. So Thor is from Moore and he is super heavy, while iRobot is from Mars and he is just heavy. So these kinds of properties can be added to the nodes. So basically the table, inside the table you will have a single row, right? That single row is considered as a node here. In case of table, you will usually have joins. That join is considered as this particular relationship. Now you might be thinking, Kamal, iRobot is a name, Thor is a name, and both of these names will be coming under a single table. So are you saying that inside the tables, each and every row can also have relationships? Yeah, that is the one of the difference that we find out. So each and every element inside a table can have their own relationships, and that particular relationship we can actually model it inside the RDBMS also, but it will be awkward. But in case of graph database, this is very intuitive. And once you understand the relationships, and once you understand, I mean, you have to figure it out. It's the way I will be introducing, I believe that you will be able to figure it out pretty easily. And so once you figure that how the relationships, how the rows and columns work together, and how you can query, okay, this is the key point. Now, how to query the graph. So in case of the Neo4J, what has happened is Neo4J team has created something called a Cypher query language. Basically, it's very similar to structured query language, that is SQL, but this has very different types of functions, and but it does the same kind of activity. So for an example, all these are the various functions like Cypher functions which can do the activities like create labels, nodes, and relationship. Match can return. It is like matches like select, and it can set this like insert. delete is like, removing, dropping the rows. Match and delete, so this will delete all the data. So keep this particular command very carefully. So if you use it, then you are going to lose all the data. And load CSV is going to load the CSV files that you have got into the database directly. Before we go dive into this, I would really suggest that you guys have to work with single node creation. So I'll be going deeper into that. So let me come back to it later. Okay, let us go back. So I started speaking about relationships, I started speaking about graphs, and I immediately jumped into Neo4j. And Neo4j is a place where you can store the graph. Okay, so the graph you see here, so this kind of graph and this kind of graph. So if you go, all these graphs can be stored inside Neo4j. It is kind of a database. And this database has Cypher query language that I already introduced you, but I have not gone through it in detail. The point I wanted to talk about, so I have spoken about most of these points here, how the rows are like individual nodes, and how the foreign key that we use for joining is like relationships. There is also a way to create visualizations. So you already saw Neo4j, that is graph database, is more visual in nature. Apart from this, there are various other types of visualization also possible. But why we need graph database? I already told that knowledge graph is can be easily expressed in graphs. So if you go back to the browser and if you take a look at this particular blog, Thomas has already told or showed how the text can be converted into graphs. So these are the people who have worked on OpenAI, and the relationship is worked at. So how will you store these kinds of information? So Neo4j and graph database renders very well for this particular application. But apart from that, that is the main inspiration why I'm making this particular video. But apart from that, Neo4j and graph database can help you in doing a lot of other things, like visualizing the node properties, understanding or intuitively gaining the knowledge about a particular graph or dataset. In fact, one of the most complicated datasets that is available right now is Marvel comics dataset. So it is the relationships between the comic numbers, the comic issue numbers, and the characters, their timelines is actually pretty complex. To create such a kind of use those data and to create relationships is very easy. I mean, it's not that easy, but compared to using RDBMS to create those relationships, using graph to create those relationships is very, very easy. So such a level of applications are available with graph database and Neo4j. The next important idea is that you can go any depth inside the graph and you can try to find the insights. So if you have a very large number of options and there is going to be lots of choices involved, you want to understand how the customer is going to navigate those choices, yes, then you are going to use graph database. Apart from that, I already told about knowledge graph that will be used for providing the relationship between the entities, that is entities like person, place, location, person, location, the verb, parts of the speech, and how it is linked with the particular document. So these are the various challenges that graph database solves. Graph database or a graph, in fact, contains a node, as I already explained. Node contains various properties, and the node can have relationships, and the relationships will have directions, and these nodes and relationships can be clubbed under a particular label. So label, we can think about it as a table inside our SQL language. So all the product related nodes will be in product label. All the employee related nodes will be under employee label. So like that, we can create labels. And in fact, if you when you actually create labels, so you will have a different color to the labels, right? So if you come down here, so these are all two colors. So these blue colors are all about authors, and this orange color is all about profession. I have created two different labels here. One is profession and one is authors. So you see the difference is visual in nature when you are going to work with Neo4j. And this is one of the benefits of working with Graph also. So here you can take a look at all the data. It is spread out, and there is no any particular relation here. But here the relationship has been created, and here Dan number 2 belongs to Dan Brown, number 4 belongs to Walter Isaacson. So basically number 4 profession writer belongs to Walter Isaacson. Instead of belongs, I can say 4 is Walter Isaacson. So we can actually create a kind of a relationship, like Walter Isaacson is a writer, Warren Buffett is a investor or a writer. We can say Andrew Carnegie is a millionaire. Like this, we can create actual relationships, and which is much more detailed in nature. All these things I will be introducing you how to do this in a couple of minutes. But now we have seen what kind of steps we have to take in order to understand and create nodes. So you need to have data. You can actually start creating nodes, and in order to load the data into the Neo4j graph database, there are all these commands. That is, we'll be actually going through these commands one by one. And for going through these commands one by one, we'll be using this data. This data and as well as this data set is already available in the, just a minute, let me go to the browser. And if you go to this particular repo, Insight Builder Python delearners data, and if you go under exploring Neo4j folder, you will see all the data already available. Okay, so this is all fine, but there's still this nagging question. So Kamal, how is all these things linked with Langchain? Why have you placed, how is Neo4j linked with Langchain? What is Langchain doing here? As I was going through the let me go back to the browser. As I was going through the various blogs that was written by Thomas, he had specifically written about, he has already linked Langchain with these with this Neo4j instance. So he has already spoken about that. Then I went to Langchain and I found that okay, Langchain has already got a tutorial on connecting Langchain with the Neo4j also. So that is where the actual research started for me. So once I understood Langchain can connect with Neo4j, then I had to do some connection to the Neo4j database, and I need to start querying, right? Then I realized, so in case of the tutorial that has been provided in Langchain, they try to provide a minimum data. So they create a small database where they create a movie label and actor label, and they try to create a small connection. Okay, and then what happens is they immediately start querying it. The problem with this kind of an introduction is people who are new to Neo4j will not be able to learn anything out of this, and I was completely new. So then I realized, okay, I have to learn about Neo4j from the basics. Before doing that, before actually I take you through the journey of learning about Neo4j basics, I would like you to see what happens. Okay, so basically what this particular notebook that you are looking here has is connecting the Langchain interface, Langchain classes. You see the Neo4j, Graph, Cypher, QA chain, chat vectors, AI. All these are Langchain classes, and these classes are connecting with Neo4j database, and it is querying the Neo4j database. So you see this particular query, this is actually a Cypher query. All this is happening, and this particular notebook will be shared with you guys. It's already available here in this same place. If you go to trying Neo4j Vertex AI, you will be able to find that. The point here is what we are going to query, which database we are going to query. So for that, we will be using one of the tutorial that was provided by Neo4j itself. In neo4j.com, if you go, there is a tutorial called as Northwind ETL. So this particular Northwind ETL tutorial helps you to, just a minute. this particular tutorial. So I'll be sharing the link for this particular tutorial. Also, this particular tutorial explains to you how to import the data from CSV file into Neo4j database. And in order for you guys to speed up your learning process, there is something called as Neo4j sandbox. So if you come to the, I think it is available in the, just a minute, I think it is available. So if you click here, it will actually go to the sandbox. So you can sign up for Neo4j account by using your Google, and you can actually get a sandbox access to a Neo4j database. And once you get the sandbox access to Neo4j database, so they will ask you to accept this agreement. They will ask you to tell where you are working. So you have to just give the location where you are working, and you will be in no time. After that, you can create a blank. It's very important. You have to create a blank sandbox. So there will be lots of other kinds of sandbox that you can create, but create a blank one. The reason is, once you create a blank sandbox, you can, not that. So once you create a blank sandbox, you will be given the connection details. So this connection details, and once you create this blank sandbox, you will be able to change the password. So I'll be showing you how to do that. So once you get this connection details, you can come here and you can fill that connection details here. So this is what I've done here. Okay, and then you have to use the username and password, and you can start working with the working on this particular notebook. And if you also visit the Langchain, what is it called? Langchain tutorial inside, they would have told you that you have to install the additional applications also. Say they talk to you about installing. In case of this, they are talking about Neo4j instance or Neo4j database application. And apart from that, in order for Neo4j graph class to work, you have to do a pip install Neo4j. So you have to do that also. Then only you will be able to log into this particular. Instance. Just a minute. Basically, you have to install all these libraries before you start this particular notebook. And also, once you install all these libraries, ensure that you do a runtime restart. Why I'm telling you need to do a runtime restart is because if you are going to use Cloud AI platform, you have to do a runtime restart. Or else this particular cell, when you initiate it, it will fail. It will state that some of the libraries are having a conflict. So basically, you have to do a runtime restart. Once you do that, then you will be able to execute this, then you will be able to get this output. In order to get this output, you have to load the data that is provided in this tutorial into this particular sandbox. And this particular sandbox, that is where you can start. So once you load all the data, I'll be showing you how to do that in a couple of minutes. But once you load it, then you can actually execute this. And if you come here, I'm asking, okay, how many products did each customer purchase? Once you execute this particular query, okay, it's connecting here. Once it connects, I'll be able to query it. So once it is able to connect it, so you'll see that it is creating the Cypher query language itself, and it is providing the data. If you take the Cypher query language, and if you go to the database, and so the same query language I'm using here, and you'll see the same answer is coming. So what this means? What this means is that Langchain has created this particular graph Cypher chain QA chain, which internally has a prompt that will ask the large language model to create Cypher query language. So how did I know this? Let me show you. So Thomas has already explained this also. Thomas had explained to me about the challenge that he was facing when he was trying to get the large language models to create the Cypher query language. So he had shown how the prompt template can be created. This prompt template, you see, this prompt template has been taken from the graph QA chain prompt template. So if you go into the develop code of prompt QA chain, you can take a look at this prompt format. So here we are actually giving the Cypher example. So how many streamers are there? This is taken directly from Thomas' example, and these two I have added additionally. So this is second example, and this is third example. and I am giving an example to the large language model, and then I am requesting the large language model to generate the Cypher query language for this question. And then I run the query. So here, this is one another query which I have, okay, this is going to error out, most probably. Yeah, it's going to error out because I did not properly execute everything, right? So let me execute this. So don't worry about that. I will be, going into the details of creating Neo4J database in a moment. So I'm just showing you what is possible, so that at the end of the day, the most important thing is you should know what is the end goal that you are trying to achieve. Here, what are the various products supplied? So these are the various products supplied, and this is the query language this is the Cypher query that has been created by the Bard LLM. This is not by ChatGPT, this is by Bard. You can use ChatGPT also, and you can use any other LLMs also. Ensure also there is a discussion. If you take a look at this particular repo, it is about fine-tuning the large language model to create Cypher query language. You can take a deep dive into this repo also. And also, if you have any questions and queries, do let me know. I believe that you actually have learned a couple of things already. So do leave a like and share it with others. This particular information, and especially knowledge graphs and how the knowledge graphs is linked with document retrieval. Most of us are facing the challenge these days with document retrieval. So share it with your colleagues and your friends, and subscribe to my channel for further update. And further update on not just language models. I discuss about the entire ecosystem around Python and the challenges the ecosystem solves. This particular video, as I was already telling, I am not directly going to solve the problem. That is the problem of improving the vector search, the multi-op vector search. That is not going to be solved. This is a primer on Neo4J and KnowledgeGraph. So I want you guys to use this particular video as a starting point where you can get where you install Neo4j, or you get a hang of Neo4j sandbox by getting an access to it, and start querying it in your free time. And then once you are comfortable with it, then the next step will be to create knowledge graphs of your documents, load it into Neo4j, and then use large language models to query it. So that is a topic of another video. So do subscribe to my channel so that you will get some updates on that video also. Moving forward, what we are going to do now. So I had already shown you that if you go back to the discussion, I was telling you what is happening in Langchain, how it is getting linked to Neo4j. This is all fine. So I have given you, I can close this particular video here, because I have introduced you Neo4j. I have introduced you how to connect Neo4j with Langchain. The challenge is actually not connecting with Neo4j. The challenge is, understanding how the graph input actually works. How will you, load data into graph or a graph database, and then how will you query it back. So these are the two things that I want to touch upon in this particular video in another 15 minutes. So I believe that you will need that, because once you understand that initial steps, right, then speeding up from there is very easy. What I would like you guys to do is you can get access to the blank sandbox using the Neo4j blank sandbox, and get an access to it. And once you get an access to it, click on open. So once you click on open, I'm going to close this particular page. So once you click on open, you will get a particular window like this. So let me run clear here. So once I run this clear, so you will get a window. This is like this, and you will also, this will get populated. This particular interface, this particular browser interface is what we are going to use for querying and creating graphs in Neo4j. You see this particular, so if you click on this particular icon, you will see the database that is getting listed here. There will be two databases by default, Neo4j and system. There will be two databases. And if you click on favorites, you can save your favorite queries that you write here. And then here is about importing data. If you are going to have your own Neo4j instance using Docker, or you are going to install it in your local machine using Windows executable, then you will have a tutorial in this location. where they talk to you about the basics of Cypher query language. They also introduce you to 2 tutorials where they introduce you how to import the Northwind database, that is this particular tutorial, and they also talk about one more basic tutorial. So they introduce you, and the way they introduce, Neo4J team introduces the concepts is very, very interesting. So let me show you some of the information. So if I click on colon, if you do a double, if you enter colon into the bar, you will see that you can immediately ask for the help. So you have to press Control Enter. So then only it will work, or you have to click this play button. Once you click on, once you enter this command with colon help, you will see there is a lot of other commands that gets listed down here. So let me zoom in a bit so you can see it better. And now what we want next. There are a couple of examples here. So click on play Northwind graph. So once you click on play Northwind graph, you will see that it will go through the step-by-step process of actually importing the this particular tutorial is there, right? It will actually go through the process of importing it step by step. So you don't actually need to do anything. You have to just click this, and the entire command will get pasted to the execution cell, and you have to just press play. So and your data will get entered. And I urge you guys not to do that. So yes, they have made our life really easy, but one of the challenges that once you use these kinds of commands and you start uploading it directly, you will not be able to learn anything. Okay, so let me go back to the PDF. I always say that you have to practice, and most of the time, almost all of the videos that I share, I create or I tell about a platform where you can practice, or I create a set of data, or I try to show you how to practice, right? So this is also going to be like that only. So I am going to show you a couple of ways to practice, so that it will be much more effective for you to move forward. So first and foremost, you guys have to do one thing, that is to create a single node. This is what you have to achieve. After you create a single node, try to create another one and try to create a relation. After you do these things, then and only then you can go to the next step of using the load CSV imports. Once you follow this process, you actually understand. Once more complicated activities like match and merge, etc. comes into picture, you will understand what is going on. So let us start. So I am going back to the browser, and in the browser I am in the sandbox. Okay, one more important thing I forgot. So if you want to change the username and password, you can actually click on server user add, and you can add usernames here. So if you are facing any problem in connecting to Langchain, connecting Langchain to the Neo4J blank sandbox instance, then you can come here and you can create a new username, you can create a new password. Don't click on this particular force password change. Don't click on this. You should not click on this. Okay, just leave it empty and then say add user. After that, you can go here and you can start working with that. Okay, so this is one thing that I missed out, and you can use colon clear and control enter to clear the various cells the Neo4J interface has created, and you can start with the blank interface and also each of the cells. So let me show you something. Let me first of all show you what is there inside the inside this database. So inside this particular database, I already have these labels. So I have already created category, employee, order, product, and supplier. So let me show you what is there in supplier. Let me click on supplier. And what I'm going to do is I'm going to say return n and limit 5, and I'm going to press enter. So match is going to match all the elements in the supplier under the supplier label, meaning it is going to match all the elements in the supplier table. So if you are from SQL background, then think about it that way. And then return is going to return all those elements, and this limit is going to limit it to 5 elements. So that is the meaning of all this. And once you see that, it actually creates all these things, and you can use control scroll to change the zoom size. You can move, you can click on this to close this overview, And most importantly, you can click here and you can edit it also. So if you want 7 points, so you can just edit it to 7 and it will update to 7. So this is very user-friendly interface that I have come across. And if you click on this table also, you can see the details in the tabular format. This is actually a JSON format, but in a tabular way. You can take a look at the text also. This is very similar to the command line output text, and I prefer graph. So we'll be using text and tables in some other location. Now, one more important point. Now what we are going to do is, so let it be there. What I'm going to do is match. So I'll come to the single node. Okay, I'm showing you some other interesting things so that you guys can use it when you are creating the single node. So I'm going to use product. And what I'm going to do is I'm going to say return n dot product ID and n dot product name, and I'm going to limit it to 5, and I'm going to press enter. I'm going to press Control Enter. So once I press Control Enter, you will see, yeah, this is like exactly like how you will get the table in SQL. So what I did, if I click here, I matched the pattern for I wanted the table match in product, and then inside the once I match it, I am asking to return product ID and product name. So this product ID and product name are the properties of the node. To access the properties of the node, we use the dot operator. Like this is very similar to how you use dictionary terms inside Python, right? So it is very similar to that. Let me go down a bit, and if you click on this, and if you click on the overview, you will see, okay, let me do that. So let me change it to product so that it will be easier for you guys to understand. This is one of the benefits of working on Neo4J interface. I think it's going to say, yeah, I think it is wrong because the label is not there. I think product will work. Let me see. Yeah. So you see the product is working, and I have asked for 7 products. And if you click on 7 products, you see these are the various entities. These are the various properties: product ID, product name, and unit price. And when I'm going to ask in this particular location, I'm asking for product ID and product name. This is how you actually query the data that is already inside the database. In order to first of all push the data into the database, we have to start somewhere. For that, we have to use something called as create. You have to use create, and we have to create the label. First, we have to create the label. So I am going to say L for label, and I am going to say temporary label. So this is the name of the label I'm going to create. And once I create this temporary label, now I am going to create the first node. So the first node, I am going to name it. So what is the name I'm going to give? So name is iRobot. The same thing that I showed you guys in the presentation. So if you go back to the PDF, I had created the first node, right? So this first node, this is the first node that I created, iRobot. The same thing, I'm creating it again for you guys to take a look. So let me go back to the browser, and here I've already created the label. So I've given the properties as name, iRobot, location Mars, and weight is super heavy. This has been created. Now how am I going to query it back? I need to look at the node, right? For querying the node, what we are going to use is match, and this bracket, open and close parenthesis. Inside this parenthesis, if I give any variable, so n in this case is a variable name, and I want this variable to link with temp label. So I want the data from the temp label, and I want to return the n. So this is what I want to, this is what this particular query does. So once I execute this, so this will return the iRobot data. So you see this is what I was talking about. And once you click on this, you will see that it is location, name, and weight properties have been showed. And this arbitrary ID has been created randomly. And this is the label that we created. Now let us create one more. So if you want to look at the history of what commands you have used, you have to press Control on your keyboard and press up arrow and down arrow. And now I am going to create new variable, and the new variable is tar. and Thor is from, let us make it Asgard, and he's super evil, right? He is a god. I'm going to create this and I'm going to press enter. So once I press enter, so this has been created and 3 properties has been set, completed after 1 second. So now we come back here, and if you execute this cell again, now you'll see that I have 2 data here. So one is Thor and one is iRobot, and here still there is no any kind of a relationship. There is no any kind of relationship created. Next, what we are going to do is we are going to create relationships. In order to create relationships, we have to still use the create option. Here, apart from, you have to create relationship between 2 nodes, right? So you have to first of all select the nodes. In order to select the nodes, you have to use match operation. So what you're going to do is you are going to say match. Okay, before we go into the creating the relation, let me show you how to do the filtering. So let us create match in temp label, and we are going to still use temp label, where n dot name is equal to iRobot. This is what the condition or the filter that I'm going to use, and I'm going to return n. Okay, and once I execute this, it is returning only one label, and that is iRobot. So this is how you actually do the filtering. So you use this where clause to do the filtering. And if I change it to Thor, I'll be getting the Thor. I'll be getting the Thor node. So I'll be getting the complete Thor node. But I want to have both of these nodes, and at the same time I want to create a relationship, right? So that is done using a different way of filtering. So instead of actually using where clause, what you do is you actually use this kind of open close bracket, and if you do a match like this, then if you try to return, it will actually return the filtered data. So this is a short form of using the filtering. So this particular match also will return the same Thor node. Okay, so the internet is a little bit slower. Sorry about that. So if I use this particular format where I initiate the label and I give the name directly, name as iRobot, then this will become the filter. And once I execute this and I ask it to return the node, it will return the complete node, iRobot node in this case. If I change it to Thor, it will return the Thor node right now. As I was telling, this is how you access each of the nodes. There is a different way when you are going to access a lot of nodes. Don't worry about that. Right now we are going to access only 2 nodes. So one is the Thor node and the other is the iRobot node, right? So what we are going to do is we are just going to copy this, and just give me a moment. And what we are going to do is we are going to paste it here, but instead of Thor, we are going to use iRobot, and we are going to change this variable to I, and I'm going to return both n and I. So once you execute this, control enter, what is going to happen is it is going to return both these nodes, but this time I used a different format. Okay, I did not use the regular match n and match n temp label and return the n nodes. No, I used a different method. Why? Because what I'm going to do next is I'm going to create the relationship. I'm going to create a relationship between the Thor node. So in order to create a relation, you have to have this kind of a hyphen, and you have to have a square bracket, and inside the square bracket you have to give the colon, and you have to create the relationship, and then you have to again close the square bracket and give an arrow mark. So this is the directional arrow mark that we provide, and I'm going to say, in this case I am going to say Thor met iRobot. So n variable is Thor and I variable is iRobot, and I'm going to execute this. And once I execute this, so you will see that one relationship has been created. And now if I go up and let me actually go here and let me run a simple match function, and I say n, and I say that temp label, and I am going to return all the n. Okay, and now you'll see that there is a relationship built into this. So you see the relationship that Thor met iRobot. Now, what if I want the other side relationship also? It's pretty simple. Okay, so initially what I was thinking is, let me tell you what had happened. So I wanted to create both the sides relationship. Okay, so what I did, I actually tried this. So I created both this side and that side arrow mark, and I expected that, okay, it will work, but it doesn't. So see what is the error that comes in. So you will see that it is not acceptable. Only directed relationships were supported in create. So you cannot have both the direction available. The option is that you just change the variables. So instead of I to n, so instead of n to I, I'm going to say I to n. So this time what happens, the new relationship gets created, and then if I go and check the graph, then you'll see that the relationship both up and Thor has met iRobot and iRobot has met Thor. So this kind of relationship has been created. So let us go back to the browser. Now we have understood this particular slide. Okay, and this is where the starting point is. So once you are able to understand these steps, then moving to creating the actual database with lots of data inside that can be possible. And for creating that lot of nodes inside the database, the process is very similar to using create, but we will use the load CSV option. So I'll be showing you the example with this table and this table. So next is that is what we are going to see. And for that, we have to use the load CSV function. Let us go back to the browser. And this particular, the data is already available in this location. So all you need to do is go to this person.csv. If you click on person.csv, you will open this file, click on raw, and then select this link, and then come back here, and here you have to say load CSV with headers from. Once you give this, then you have to give the entire link, and you have to say as row. And before I go further, I want to show you what happens now. So I'm going to say return row. So I'm just trying to return whatever has been read. So once I execute this, you will see what happens right now. So you see that whatever data that it is reading here, it is actually this particular command is reading, and once I say return row, it is printing it here. Why am I showing this to you? Because you need to understand this step. So what is happening once you load this with headers, and next what you can do is you can actually start creating the data set. So in order to create this particular CSV file into a table, you have to use create, and you have to say let us give an x variable, and I say person is the name, or I can say, yeah, let it be person only. And once I say create person, and next I am going to say set x is equal to row. So what this will do is it will take all the data, all this data, and it will create nodes under the label person, and it will actually add all the values in the row, that is all the data inside the row as properties for the nodes. So this is what this particular example will do. So once you execute that, then you will see that file labels has been created, and okay, so this is let us see now match n, and I'm going to say person. So person, and I'm going to say return n. So this time I'm asking for the person label. So this is a new label that has been created, and you see that this is the label that I created, this data. So Walter Isaacson Framebook DaVinci, ID equal to 4. So this is the data that I was talking about. So now the nodes has been created. The same way, so all we did was you have to use this particular load CSV, create person and set x equal to row. And like this you can, let me go back to the PDF. And like this you can import the other data PDF also, other library also. And once you import this other CSV file, this particular CSV file contains the profession, and the profession and the author name, in this case the fame book, the book that made this author famous. So iRobot and the author name. So we can see this author name is constant between this table and this table, and you can use this author names to create the relationship between their profession and their book. So this is what I was talking about. So using this, you can actually create the relationship. And these are the various commands that you can use for creating the relationship. That is what I have provided here. This is kind of a simple exercise that you can do. And then after doing this, once you are successful in this, it is going to be a little challenging. I'm not going to go through this process. I want you guys to try it out. So as I always say, practice. And this time I want you guys to practice this. And there is a very good genuine reason for this. As I was telling, now we can actually create relationships, right? You saw that if you go back to the browser, we can actually create relationships that you saw here between Thor and iRobot. Like this, you can create relationship inside your documents, and you can store these documents, and you can also do the vector embeddings also. And apart from that, once you create this relationship, you can query it using Langchain. But in order to query, in order to even work with Langchain, work with Python, etc., you need to first of all have the data inside the database, correct? And you need to know how to load the database and how to create the relationships. I would suggest that take a look at, try to experiment till this particular step where you get this right. And after that, try to go through this tutorial. Or you can use the tutorial that I showed in the beginning. You can use help, and once you execute this help using control enter, you can use either play movie graph or play northwind graph. Play movie graph will be much more easier for you guys. So this is this gives a different input. You guys can try this first, and then after you understand each and every step of this, after that you can actually go further and you can work with the excuse me, let me go back, work with the play northwind graph. Once you are done with play movie and play northwind graph, once you are done updating all the northwind graph steps, after that you can check this particular notebook and you can execute it, and you will be able to execute it without any doubts. So let me go back to the browser PDF. I believe that this is a very different way of introducing multiple tools. The reason why I am doing this in such a jam-packed setup is that this is what is expected out of all the developers. And the leaders, business leaders, or the product managers or the product owners, they have to see the results, and they don't really need to understand what kind of strategies or tools or applications we are using under the hood. They still have to decide. They will, talk about the latencies, the speed with which the customer accesses the data, all those stuff. But at the end of the day, as a developer, you must know various methods to solve a single problem. Neo4J is one of such solutions, or one of those methods which you can use to solve a problem of retrieving the documents for question answering. And I believe that you will like this challenge. And it took some time for me to even understand Neo4j. It took some time for me to practice it. In fact, it took almost an entire day for me to break and redo all this activity, redo all this exercise. So it takes time. You give time, at least you give 8 hours to all this activity, and you will be able to master it. Just 8 hours. I have already given the locations of how to get the guide, this particular guide. So this guide I was talking about. So this is already shared in this particular location, and I also shared the Python Langchain docs location. I'll also be sharing the Mr. Thomas blog in the YouTube description. So do take a look, and also the entire the notebook, Jupyter notebook that I used for this particular discussion, that also will be shared. The point I want to reiterate here is that the Neo4j is a different kind of a database, and Neo4j is not just about being a database. Neo4j can be extended into doing data science also, and they have an entire library that works with data science related algorithms, and not just simple regular algorithms. They use graph algorithms, and most of the graph related ideas has been already converted into functions, and all these functions are available for us once you understand Neo4j database and how to work with it. In the next, let us go back to the presentation. In the next following up video, I would like to further extend this particular discussion, and I will be showing you how to create knowledge graph with the documents that you have got, and then query the documents using Langchain. So that is my next step. And apart from that, I will be also showing you a couple of information how to work with Docker environment of Neo4j, and what are the challenges that you will face there if you are going to use Docker environment. You will face a considerable amount of challenges if you are going to use Linux, because Docker is best run with Linux. You can use WSL in Windows also. I would suggest that take a dual boot and do it in Linux. That will be much more easier for you guys, and that will be my next objective. With that said, I would like to leave you guys with 4 words as usual. That is practice, 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 practice. See you guys. Have a great time.